Hi there. Today's lesson is on the Triangle Midsegment Theorem. So our first vocab word of the day is midsegment. And the midsegment is any line segment that connects two midpoints. So in this triangle, I have the midpoint of this line, which I've put a point right here for that midpoint, and I have a midpoint along this line, which is right here. And I know that these are the midpoints because you can see that I've labeled this half with one tick mark and this half with one tick mark, and they're the same. So the midpoint, right, it's in the middle of that line, and I know this is the middle because the length on either side is the same. So the midsegment is a line that connects two midpoints. It's usually in figures, so it connects two midpoints. The Triangle Midsegment Theorem is our theorem for the day, and it states that a midsegment, a line like that, connecting two sides of a triangle is parallel to the third side and half as long. So I know it's parallel, so I can go ahead and put in the parallel symbol, indicating that those two lines are parallel to the third side. So that's really important here because it's connecting the midpoint of this side and this side. The only side of the triangle it's not interacting with is the third side, and the side it's parallel to. And it's half as long, which you can see that I've put the midpoint here, and I've labeled each half with 3 tick marks, and I've labeled the entire midsegment with 3 tick marks, meaning that half of this length, or just like from the midpoint to an end, is equal to the midsegment. So that's the Triangle Midsegment Theorem. This image serves to show as an example that there's not just one midsegment in a triangle. There is in fact 3. So if I connect these two midpoints, and I've drawn the 3 midpoints here in different colors to show that where that midsegment is, that it's parallel to. So I have my 3 midpoints, and I know they're my midpoints because you can look at any of them and see that the same length is on the left as it is on the right. Same on the left as right, and left as it is on the right. So I have my 3 midpoints, and I can connect any 2 to form these 3 midsegments. For example, this red one. This is the one that similar to the one we saw on the last slide. So this midsegment is parallel to the third side, the side it's not interacting with, which is this one. It's connecting this side to this side, so the third side, and half as long. This length is equal to this length, or this length is twice as long as the midsegment. Same thing if we look at this green midsegment. This green segment is connecting these 2 midpoints. It's parallel to that third side, and it's half the length. So this is equal to this. We can also see that with the blue one. So the blue midsegment connects these 2 midpoints, is parallel to the third side, and this length is half of this total length, the total length of this side here. So again, there are 3 midsegments in every triangle. And in fact, the 4 triangles that I've drawn by connecting the midsegments are all congruent, and we'll prove that in a few lessons. The Triangle Midsegment Theorem is extremely helpful when trying to solve for algebraic problems using triangles. So here I have a line that connects the 2 midpoints of my triangle ABC. And I know that these are the midpoints because as I look at this, I know this is 4 and this is 4, this is 5 and this is 5. So I know it's the midsegment because this is the midpoint, that's the midpoint, and it's just the line connecting the 2 of them. I've labeled as X. I'm trying to figure out what is the length of that midsegment. I also know that BC has a measure of 6. So that's all I've gotten so far from just reading the figure that I've been given. And the Triangle Midsegment Theorem tells me that the midsegment connecting the 2 midpoints is parallel to the third side, the side it's not interacting with, so I can go ahead and draw the parallel symbol. Those are parallel, which will be really helpful when trying to prove angle relationships here, but for now they're parallel, and half the length. So I know that if here's my midpoint and I label this with 1 tick mark, this is 1 tick mark because it's the midpoint, so each is the same. And I know that if this is half, this also gets 1 tick mark. So if this is 6, let's solve for x. So I know that BC is equal to 2 times the measure of DE, or I can say that half BC is equal to DE. Either way, this works. These are both saying the same thing, that twice the midsegment is equal to this third side, or half the third side is equal to the midsegment. And from here I know that this is 6. BC is 6. So I can say 1/2 of 6 is equal to DE. Half of 6 is 3, and that is the length of DE, and which is x in this case. So that's the length of x. Checkpoint question. If BC were 10, what would be the length of x? So instead of 6, this measure is 10. Go ahead and find x.